Welcome to the first lecture of Mathematics in the Modern World, Mathematics in Our World, an Introduction. By the end of this discussion, or module rather, the student should be able to identify patterns in nature and regularities in the world, articulate the importance of mathematics in one's life, argue about the nature of mathematics, what it is, how it is expressed, represented, and used, express appreciation for mathematics as a human endeavor, and recognize number patterns and identify succeeding terms in a number pattern. Take note that these objectives will be met by Lecture 2 and Lecture 3. The human flourishing and the natural instinct for survival had paved the way for ancient people to come up with mathematical philosophies and discoveries that would eventually shape the world. Here we have mentioned human flourishing and natural instinct for survival. Do you know what human flourishing means? Human flourishing is living a good and meaningful life by developing your potential, achieving well-being holistically, and acting virtuously. So if you have taken the course Science, Technology, and Society, you must be familiar with the Greek term eudaimonia, and that is connected to human flourishing. Next, natural instinct for survival. Of course, the ancient people had to discover some skills for survival using mathematics in order for them to survive. Without keen observation, calculation, precision, and accuracy, the ancient civilization would have never passed on to us their valuable contributions to the society. On the image on the right, you will see the pyramids of Giza in Egypt. You will see how meticulous the Egyptians were in building the Egyptian pyramid. Take note that these pyramids are around 4,500 years old. These pyramids are not just stacked up stones or blocks, but they contain chambers and tombs. The development of mathematics started all over the world until combined universally so as being used by the modern society. So from STS again, or from your own knowledge in history, how would these concepts got combined universally? Of course, you know that ancient people would do trading. These are some of the mathematical skills during the ancient time. Counting. Ancient people knew how to count already. Why is that? They needed to account their resources so that they would know whether these resources would meet their needs or not. Next, innovating and logical reasoning. There's a lot of things that we are using until the modern era that were invented during the ancient times. It's because ancient people were known to be innovative and resourceful. Logical reasoning. You know that mathematics is a branch of science, and science is an emotionless feat. So mathematics is also emotionless. That's why everything that you do in mathematics must come from an organized thought, which is logic. Everything that you do in mathematics must come out from a good reason and supported by laws, axioms, and any other concepts that are valid and factual. During the medieval and Renaissance periods, science and mathematics had a huge development as technology unfolded as well. The development of calculus and physics in the 18th century, among others, would eventually lead the world towards global industrialization. Fast forward to now, in our everyday lives, mathematics is used. Whether you say that you fear or hate mathematics, you are still doing it in your everyday life. When you buy street foods, you count the quantity and its cost. For commuters, you count the fare and your change, to mention a few. These are 6 of many important applications of mathematics. Number 1, mathematical physics. Here, you discuss about the speed, velocity, forces, measurements, and other phenomena, physical phenomena. And you know that they all use, and you know that many concepts are represented or modeled by equations. Number 2, mechanics. So just like in physics, we study about the behavior of physical bodies when subjected to forces or displacements. Third, engineering. You know that engineering has a lot of branches: civil, mechanical, electrical. All of them are applied sciences. And without mathematics, they would have never existed. Number 4, pharmaceutics and internal medicine. 5th, ecology. 6th, agriculture. All of these use mathematics. Now let's talk about the 17 equations that changed the world according to Ian Stewart, a British mathematician. Number 1, Pythagoras' theorem or Pythagorean theorem. So this one states that for any right triangle ABC, the sum of the squares of two sides is equal to the square of the side opposite the right angle. So take note that this is the right angle, 90 degree. Okay, and take note on how the sides were named. This one is vertex A or angle A. This is the opposite side to it, so you have small letter A. Capital B for the angle B. This one is the angle, okay? The angles. Okay. For the vertex B, the opposite side is small b. And then for the right angle C, this one, and the vertex C, the opposite side is the hypotenuse. Take note that the hypotenuse is the shortest way to go from point A to point B, instead of taking this and then taking that. So you see that you apply that in real life, don't you? Number 2, logarithms. You know that from your high school mathematics, if you say that 5 squared is equal to 25, well, 5 times 5 is 25. This one is equivalent to saying the logarithm of 25 to the base 5 is positive 2. So what does it mean? It means that the exponent 5 must have to obtain 25 is equal to 2. So that is what logarithms do. Third, calculus. Calculus is a branch of mathematics that is concerned with the rate of change, areas under the curve. Fourth, law of gravity in physics. This is being studied. Fifth, the square root of -1. Okay, the square root of -1 is equal to I, imaginary number. Sixth, we have the Euler's formula for polyhedra in geometry. Seventh, the normal distribution in statistics. And followed by these equations in physics. Normal wave equation, Fourier transform, Navier-Stokes equation, until the Black-Scholes equation. Well, these are just some of the many mathematical equations that have been used until today that have helped shape our society. For your exercise, give exactly 5 other specific uses of mathematics in your own everyday life. Explain briefly.